Alright, hey AP class, period 2, Mr. Whitcomb. I decided to do my project on child development. So there's a few people that have their ideas about child development, but the one that we will be looking at is Packett's theory, stage theory. So hopefully before I show you this video, I showed you a bunch of Google slides about his other ones, stages. The one that we'll be looking into is the pre-operational phase, and more specific, the testing about liquid and conservation. I'm gonna get a few interviews, one with my little brother David, one with my nephew Mason, and one with hopefully a bunch of little preschoolers, and see their reactions to the test. Thanks. So before we start Packett's conservation of liquid experiment, let me tell you what it is. So I have beaker A, I have beaker B, and I have beaker C. I'm gonna fill up beaker A and B with the same amount of liquid. Then I'm gonna pour beaker B's liquid into here. And according to Packett, a child in the pre-operational stage will get mixed up because just because the shape and form has changed, they'll think the quantity of water has actually changed as well. First person that we're gonna do the experiment on. So, David, how old are you?
16.
So since David's in 16, he'll be in the formal operation stage of Packett's theory. So, David, do these beakers have the same amount of water in them?
Yes.
Which one has more water in it?
They're equal.
Why are they equal?
Because you said before they were equal.
So even though this one looks like it has more water in it because it's taller, it doesn't mean it has more water. There you have it. So this will be the second person that we're gonna do it on. This is Mason. Mason, how old are you?
11.
So he's in elementary school. So right now he's in the same stage that David was in. So let's see if we could do on him. So, do they have the same amount of water in them?
Yes.
Alright, just to make it known in the video, he wasn't here for David's one, so he doesn't know what's going on. So,
They're equal.
okay. Which one has more water in it?
They're equal.
Why?
Because this one, no matter how long it is, like, so you know how, like, so you had that one in the water, and like you said, they're equal. They're both equal. So yeah, you poured that one into here, and it doesn't mean, like, since it's longer, it doesn't mean that it's more water. It
Okay.
has more water.
All right.
It's the same. That one is like, no matter like the height. Yeah.
Okay, so yeah, that makes sense. So, Packett, at the stage that David and Mason were in, he was expecting this. Like, by now, a 11-year-old and 6-year-old will understand the theory of conservation and how quantity doesn't change because shape and form changes. And the next experiment, I'll be doing it with a few preschoolers and seeing if they get the same results or if they get different answers. All right. Hey guys, what's your name?
Kat?
What's your name?
Vienna.
Nine. So how old are you?
5.
And how old are you?
5.
Alright. So this is the perfect stage right here in Packett's theory, the pre-operational stage. Alright. So, what do you want to be when you grow up?
A doctor.
A doctor? What do you want to be when you grow up?
Police.
You guys have things planned out. I wanted to be the Incredible Hulk when I grew up. You know who that is? Avengers, green guy?
Well, I want to be that.
You want to be Flash? I couldn't be Flash. I couldn't be the Flash. Alright, so I need you guys to, okay, so there's the same amount of water in this, right? You guys both think so, right? Alright. If I do this, whoa. Now, which one has more water? That one? Okay. Which one do you think has more water? That one. Alright. And if I do this again,
No, we're using those. Yeah.
What happened there? Aren't they the same?
Yeah.
Here's the thing about this. Even though this one looks like it has more water in it, when I do this, it's just taller. So thanks, Cam. Thanks, Cam.
Thanks, Cameron. Thanks.
All right. So even though it looks like it got more water, it actually just got taller. All right. So it looks like you guys aren't amused that you guys got tricked.
When you got tricked.
I did get tricked at first when I first did this. All right. Well, thanks, guys. Thanks a lot. So as we saw from David, Mason, and those two little kids, that package theory still holds up pretty well. Even though I thought in the beginning of the video kids will be a little bit smarter and they'll notice that even though the shape changed, there's still amount of liquid, but I guess he was right, I was wrong. For those little kids, that took actually a while to record because first I gotta get them to stay still, and by the end of it I had them to, they were kind of nervous to answer since I'm, I guess, like a scary new stranger of them and everything, so they looked kind of upset, but we had fun with them. I finally got them to answer the question. Alright, so hope you enjoyed the video.